Good morning, guys. Here we go with our types of reactions lab. We're going to start with each reaction. We're going to be doing 6 reactions, and I'm going to do each of those one at a time. So here we go with reaction number 1. In reaction number 1, we've got magnesium ribbon, and the directions tell us to just take our tongs, take a piece, and put it into the Bunsen burner. And we're going to stick it in the hottest part of that flame, the top of that inner cone. Make an observation. I don't know if you can see that really bright light. That is a bright light that is off. And now our shiny magnesium ribbon has turned into a white, chalky product. For our second reaction today, we are going to be doing zinc and hydrochloric acid. Okay. We will need our Bunsen burner, but not for a little while. We are going to need our test tube rack. And in that test tube, we're going to put 2 droppers of 3 molar hydrochloric acid. One full dropper. 2 full droppers. And then we're going to take a piece of mossy zinc. And then covering up that test tube with a second test tube. So as you can see here at the bottom, we are definitely having a reaction where a gas is being produced. So if you recall, we've done gas test before when we did our distillation and electrolysis lab.
Right? You think?
Has it been long enough?
I don't know. That's my question.
Yeah. Ready? And you should have heard a fun pop noise. You might need to go back and look at those notes and figure out what gas did we produce with zinc and hydrochloric acid. You can hear it sizzling. All right. Our third experiment today is using hydrogen peroxide and yeast. Now, yeast is not going to be a reactant. We actually use yeast as just a catalyst to speed up the process. So I'm going to take, again, 2 droppers of my hydrogen peroxide. And I'm going to take a small scoop of yeast. Right, we don't need a lot, just a little. And then I'm going to stir this up slightly just to get that yeast with that hydrogen peroxide, get that reaction going. As you can see, it's foaming up. So what we're going to do is turn our gas back on and light us up another flaming splint. But this time, I don't want that flame to stay flamey. I'm going to have a smolder, right? And as I touch those bubbles, you see the pop, and then my splint catches back on fire. There you go. Reaction number 3. For reaction number 4, we're going to use distilled water. I'm just going to use straight from the bottle. And a piece of calcium metal. So we're reacting water with calcium. As soon as that calcium hits the water, hold that up for you, we can see that again there is a reaction because a gas is being formed. And so to test what we are making here, we're going to test the pH of this reaction in its solution. We're going to be using 3 different test strips. We're going to be using red litmus, we're going to be using blue litmus, and we're going to be using a test strip of pH paper that gives us a color code of the type and the pH value of that solution. Okay. I know you guys can't feel this, but this is a warm reaction, and we will talk more about that later. So I'm going to use the blue litmus first. So blue litmus stays blue. Turn. Red litmus also turns blue. And now we have a nice milky mixture here. And when I test it with the pH paper, we can see that it quickly turns a deep purple color. It's really kind of pretty. And that darkest of dark purples would be a pH somewhere between 12 and probably above 12. It's so dark, right? So this is a scale that goes to the darkest purple that they've written here is 12 pH. From middle school, you may recall that a high pH indicates a basic solution, so that of a base. And so we have formed something that has a base. We've briefly talked about bases, where that bases form from that hydroxide ion. So we know that we have formed that hydroxide ion due to that calcium hydroxide that we have formed. Okay. For reaction number 5, we are going to be using sodium hydroxide and copper 2 sulfate. So I'm going to put in 2 droppers of sodium hydroxide. Maybe 3 or 4, just so we can see a good reaction here. And then I'm going to slowly drip in our copper 2 sulfate. So here I've got my sodium hydroxide, and here is 1 drop of that copper 2 sulfate. I'm going to add this 1 drop at a time. We can see that it's turning a blue color, darker than even the solution, okay? And that blue color is solid. So that has formed a sort of kind of gross looking, some students think it looks like cotton candy. Some students have referred to it like coral. It looks more like blue snot to me, in my opinion. But it's still a solid substance that has formed when we mix that sodium hydroxide with copper 2 sulfate. So for our final reaction today, we're going to be doing the combustion of ethanol, ethyl alcohol. That formula is provided for you in your home or the lab worksheet. And we're going to be using what we call a whoosh bottle today. So here is my ethyl alcohol. As you can see on the side, it says that it is a flammable liquid, right? I'm going to take my ethyl alcohol and I'm going to put, not a lot, just a little bit in my whoosh bottle. I'm going to recap my flammable liquid and put it away from my fire. And I'm just going to coat the outside of my whoosh bottle with that liquid, just to make a nice coat around my whoosh bottle. I'm even going to pour out the excess. So here's my whoosh bottle coated with ethanol. I am going to stand pretty far away as I do this combustion. Safety first. Take my flaming splint using my ruler, and here we go. Ah! Sorry. It goes whoosh.
It's conditioned response.
And so here is my whoosh bottle. It is very warm, and then you can kind of maybe see at the bottom that we did form a liquid product. So think about our products of combustion. What liquid product did we make right here in the bottom?